Hi everybody, it's Mrs. Dunn. So what we're going to be doing in this screencast, in the second part of our screencasts on rational functions, we're going to be finding the vertical asymptotes. Now here's the official definition. For a rational function f of x, which is defined, remember, from our previous screencast, the polynomial function p of x divided by q of x. Now, in this specific definition, it says p of x and q of x are polynomials with no common factors. That's important. If a is a zero of the denominator, then the line x equals a is a vertical asymptote for the graph of the function. So basically what this definition says is when the common factors are divided out, the vertical asymptote comes from what makes the denominator zero. And that vertical asymptote is going to be an equation, and the equation is going to be x equals a. So let's look at some examples. If you'll remember from that definition, we have to make sure there are no common factors in the polynomial in the numerator and the polynomial in the denominator. So the first thing we're going to do is to factor and cancel out any common factors. So I'm going to factor each of these. So when I factor it, I get f of x equals 3x minus 1 over 2 times x plus 2 for the second function. For the third one, I can factor the top and the bottom. But there are no common factors in any of these. Okay, so the next thing we're going to do is we're going to find the vertical asymptotes. Remember, the vertical asymptotes come from the denominator. So for example, what makes this denominator 0? Well, that number would be 3. And so x equals 3 is the vertical asymptote. What makes this denominator 0? Well, that's -2. So the vertical asymptote is x equals -2. Now there are two numbers that make this denominator 0, 2 and -1. And so those are our vertical asymptotes. Okay, just like we did before in that previous screencast, I always want you to make a connection between what we're doing algebraically with what's going on graphically. So on this next slide, I'm going to scooch this over a bit so that we can add the graphs of these functions. So go ahead and graph them on your calculator. So the first function, if you'll remember, looks like this, or hopefully you're looking at it on your calculator. Here's the second function. Here's the third function. Now the vertical asymptote is a line that the equation, the graph, is getting closer and closer to, but never touching. So for example, that line for the first function is x equals 3. So here's that line. You'll see these values are going to get really, really close to 3, but never touch 3. Same thing on the other side. And if you look at the example of the second function, where would that vertical asymptote be, and what would that look like? Well, it's this vertical line, x equals -2. And here we have two of those lines. First is x equals 2, and then we have x equals -1. Okay, so that's basically what's going on with the vertical asymptotes, okay? But if you'll remember, we talked about that polynomial function has to be simplified. The top and the bottom can't have any common factors. Let's look at what happens when they do. So here's another example, and we want to find the vertical asymptote of this function, x squared minus 1 over x squared minus x minus 2. The first thing we're going to do is factor and cancel out any common factors. Well, factored on the top is x plus 1 and x minus 1. Factored on the bottom is x minus 2 and x plus 1. Do you see the common factor? The common factor is x plus 1. So we're going to divide those out. And so the only denominator left now, our simplified polynomial, is x minus 1 over x minus 2. And what makes that 0? Well, x equals 2 makes that 0. and that's our vertical asymptote. But just like before, we want to make connections. So let's look at the graph of this function. So the graph looks like this. That follows with what we thought. There is a vertical asymptote at x equals 2. But let's also look at the table. And in the table, we expect there to be an error message at 2. We expect that because we knew that there was an asymptote there. We knew that made the denominator 0. Why is there an error message at -1? Well, there's an error message at -1 because that's a value that is not included in the domain. Okay, so take a look at this. So remember, if we go back to that original function, which is factored here, x cannot be equal to 2 and x cannot be equal to -1. We saw that in the table of values, right? So the domain of this function goes from -infinity to -1, -1 to 2, and 2 to infinity. It can't go through -1, it can't go through 2, okay? But what happens with that graph, you saw that example, and we saw that picture on the graph, and we didn't see anything fishy. What you don't see from the calculator version is that there is a point of discontinuity, a hole at this point. Remember, x is not allowed to be equal to -1. So there's a hole at x equals -1. There is a point of discontinuity there. If you want to find out where that occurs, well, it occurs at -1. And if you want to find that y value, you're going to plug -1 back into this simplified equation, which would give you -2 over -3, and that would be equal to 1/3. So it's at -1 1/3. All right, good luck. Email me with your questions.